Good morning to all. Today we are discussing about positive clampers. The unbiased positive clamper circuit I show in figure. In this circuit, the capacitor is connected in series to the voltage source and the diode is connected parallel to this voltage source. Okay, and the output terminal is connected parallel to this diode. Okay, and in this positive clamper circuit, the diode anode terminal is connected to the ground. Okay, and in this positive clamper unbiased circuit, we are assuming this diode is the ideal diode. Okay, and for the analysis of the positive clamper circuit, we are giving the input signal is the square waveform. Okay, and now we are analysis the positive clamper circuit. Okay, and we know that we want to analysis the any positive clamper circuit. The first we are applying the open circuit method. Okay, so in this open circuit method, the given the circuit, this diode is open circuited and we are estimating the anode and cathode voltage of the diode. Okay, with respect to this conditions, we are redraw this circuit. Then here we are get the this circuit, and here the diode is open circuited, and this is we are assuming the cathode voltage, and this we are assuming the anode voltage, and here we are connecting the output terminal. Okay, and here we are applying the input voltage is the positive half cycle of the square waveform. Okay, and in this circuit initially the capacitor cannot store the any voltage, therefore how much voltage we are applying at the input side, the same voltage we are collecting at the cathode terminal of the diode. Therefore, in this condition, the cathode voltage equal to input voltage, and already the anode voltage is connected to the ground. Therefore, here we get the anode voltage equal to 0. Okay, and now we are assuming the first condition is the input voltage is greater than 0. It means that in the given input signal, first we are applying the positive half cycle of the square waveform. In this duration, we are consider the condition is input voltage is greater than 0. Okay, so here V input means cathode voltage is greater than the, here 0 means anode voltage. Therefore, in this condition, the cathode voltage is greater than the anode voltage. Therefore, in the given circuit, the diode is off and this diode is operated in the reverse bias condition. Okay, therefore in this condition the diode is open circuited. Okay, with respect to these conditions we are redraw the above circuit, then we will get the circuit like this. Okay, so in this circuit the diode is open circuited, and here we are connecting the output terminal. Okay, and here we have the capacitor, and here we can apply the input voltage is the positive input signal. Okay, and in this condition the output voltage equal to V input, because initially the capacitor cannot store the any voltage, and this capacitor cannot block this analog signal. Therefore, in this condition, the output voltage equal to input voltage. Okay, and here we are consider the second condition is V input is less than 0. It means that in the given input signal we are applying a negative half cycle. Okay, and in this duration we are assuming the input voltage means cathode voltage is less than the 0 means anode voltage. Okay, so in this condition the anode voltage is greater than the cathode voltage. It means that in the given circuit the diode is on and this diode is operated in the forward bias condition, and this diode is short circuited. Okay, with respect to this condition, we are redraw the above circuit, then we are get the circuit like this. Okay, so in this circuit the diode is short circuited, and here we are connecting the output terminal, and here we are estimating the output voltage. So in this condition means when the input voltage is less than 0 means during the negative half cycle of the square waveform, the diode is operating the forward bias condition and the diode is short circuited, then the output voltage of this circuit equal to 0, because here the diode is short circuited, therefore output voltage equal to 0. Okay, and now we are estimating the capacitor voltage. Okay, so here we are consider the input voltage is the negative voltage, therefore here we are mentioned the polarity of the signal is negative and positive, and here we are mentioned the positive and negative, and we are apply the KVL in this anti-clockwise direction. Okay, now here we can get the mathematical expression of this circuit is minus Vm plus Vc equal to 0. Okay, so this is we are consider the Vm voltage. Okay, and the capacitor voltage Vc equal to, we can assuming the Vm. Clear? And now we want to draw the input and output waveforms of the positive clamper unbiased circuit. Therefore here we are apply the next to positive half cycle. It means that in this duration now we are estimating the this diode is open circuited or the short circuited. We know that we want to estimate the this diode is open circuited and short circuited, and again we are apply the open circuit method. Okay, so in this open circuit method the input voltage is the positive voltage V input, and initially the capacitor can store the some voltage is here we can have the Vm. Okay, and this is you can consider the minus and this is considered the positive, and here the diode is open circuited and the anode terminal is connected to the ground, and here we have the output terminal. Clear? And now we can estimating the cathode and the anode voltage, and we know that the anode terminal of the diode is connected to the ground, therefore the anode voltage equal to 0. Clear? And now here our doubt is what is the cathode voltage. Okay, and initially the capacitor stores some voltage equal to Vm, and here we can apply the input voltage equal to Vm. Okay, therefore we can apply the KVL in this loop, then we can get the mathematical expression of this circuit is minus Vn plus Vm plus Vk equal to 0. Therefore the cathode voltage Vk equal to, we can get the Vin minus Vm. Okay, and now we are estimating the output voltage also, because with respect to this output mathematical expression only we are draw the input and output waveforms of the this positive clamper unbiased circuit. Okay, so here we can estimate the output voltage, then we can apply the KVL in this clockwise direction, then we can get the output voltage mathematical expression is minus Vin minus Vm plus V out equal to 0. Therefore the output voltage equal to, we can get Vm plus V input. Based on this mathematical expression only we are draw the input and output waveforms of the this positive clamper unbiased circuit. Okay, these are the input and output waveforms of the positive clamper unbiased circuit. Okay, and we want to draw these waveforms, we are consider the three conditions. Okay, in this the first condition is the input voltage is greater than 0. At the time the diode is off and we can get the output voltage equal to V input. Okay, and the second condition is the input voltage is less than 0. At the time the diode is on and we can get the output voltage equal to 0. Okay, and during the next positive half cycle of the input signal, it means that in this input signal after completion of this cycle and next we are apply the next positive half cycle. At this time the input voltage is greater than 0. at the time also the diode is off, and we can get the output voltage equal to Vm plus Vin. Okay, with respect to this mathematical expression, we are draw these input and output waveforms. Okay, and with respect to the three conditions, we are concluding that after completion of this negative half cycle, this diode never come back to on state. It means that you can apply the next positive half cycle also this diode is off, and you can apply the next negative half cycle also this diode is off condition only. It means that this diode is not to come back to the on state. Okay, and now we are draw the input and output waveforms with respect to this mathematical expression. Okay, so in this mathematical equation, the input voltage V input equal to, we are consider the 0. Okay, and first we are consider the initially first positive half cycle, the output voltage equal to Vm. Therefore here we are draw the output voltage equal to Vm. Okay, and during the negative half cycle, the output voltage equal to, we are get the 0. Therefore here we can get the output voltage equal to 0. And during the next positive half cycle, the input voltage equal to Vm. That Vm we can substituting in this equation, then we get the output voltage equal to V out equal to Vm plus Vm equal to, we can get 2Vm. Okay, and at that time the diode is operated in the reverse bias condition and the diode is open circuited. Okay, then we can get the output voltage equal to 2Vm. Okay, so here we can mention the 2Vm. Okay, and during the negative half cycle, at that time the input voltage amplitude equal to minus Vm volts. Okay, therefore we can substitute this minus Vm in this mathematical equation, then we can get the output voltage equal to Vm minus Vm equal to 0. Okay, therefore here we can get the output voltage equal to 0. Okay, so in this way we are draw the input and output waveforms of the positive clamper unbiased circuit. Okay, and here we remember one important point is this input signal waveform is clamped to the positive side. Okay, that is the reason this clamper we are called as positive clamper circuits. Okay, thank you.